Hi guys, myself Zubairuddin Bhatt from group 324. My topic is hydrogen bond and the structure of water and proteins. I am here referring the book M.V. Walkenstein. The secondary structure of protein chain are stabilized by hydrogen bond. Hydrogen bonds also play a key role in the conformational structure of nucleic acids and carbohydrates. Biopolymers function in an aqueous environment. The spatial properties of water, which makes it an indispensable component of cells and organisms, are also determined by hydrogen bond. Let's consider the natural properties of hydrogen bond. The presence of hydrogen bond exerts a strong effect on the physical and physiochemical properties of a substance. The intermolecular hydrogen bond determines the association of molecule, association of substances, and are characterized by relatively high heat of vaporization, thus melting and boiling point, and by large difference in melting and boiling points. Let's compare four substances composed of isoelectrical molecules, isoelectronic molecules. Methane is an unassociated substance. The other three, methane is an unassociated substances. The other three are associated through hydrogen bonds. We shall compare the properties of two isomeric substances, ethanol and dimethyl ether, present in table 4.4. Ethanol contains an OH group which forms hydrogen bond and no such bond are present in dimethyl ether. Substances associated by hydrogen bond have large value of dielectric constant epsilon. For example, at 20 degrees Celsius, the dielectric constant of H2O is 80, that of HCN is 95, formamide ACONH2 is 84, and of NH3 is 15.5. The electrical constant of diethyl ether C2H5 whole to O is as low as 4.3. The structural study of crystals containing hydrogen bond shows that when two electronegative atoms A and B, like oxygen, nitrogen, fluorine, chlorine, are bounded by a hydrogen bond or hydrogen atom, the distance between them, that is radius between A and B, is smaller than the sum of van der Waals radii. The sum of these radii as follows: 0.28 nanometer for two oxygen atoms, 0.30 nanometer for oxygen and nitrogen, 0.33 nanometer for two nitrogen atoms. In the presence of hydrogen atoms, the distance is reduced to 0.255 nanometer. In OH, O 0.28 nanometer, and in OHN 0.288 nanometer, and in NH 0 and 0.310 nanometer in NH N bond. Thus, the hydrogen bond and the structure of water is also present in the proteins. Bond reveals itself distinctly in optical spectra. Characteristic vibration frequencies of groups in hydrogen form a hydrogen bond. For example, in monomeric formic acid HCOOH, the vibration frequency of OH group is 3682 centimeter, and the dimer stabilized by hydrogen bond is equal to 3080 centimeter. The other frequencies of monomers are also changed. The infrared absorption band of OH group are strongly broadened when a hydrogen bond is formed, and there is densities are enhanced. Hydrogen bonding affect electronic spectra shifting transition to the short wave side. In proton magnetic resonance PMR spectra, there are observed chemical shift caused by hydrogen bond. The proton magnetic resonance spectroscopy is the most efficient method of studying hydrogen bond. Listen it carefully. The PMR spectroscopy is the most efficient method of studying hydrogen bond. The hydrogen bond energy is determined from the thermodynamic property of substances. From their spectra, the thermodynamic functions are expressed in terms of equilibrium constant, that's K. K is equivalent to activity of a substance divided by product of activity of reagents. The square brackets shifting signifies concentration. The free energy of formation of hydrogen bond is given as delta G is equivalent to delta H minus T delta S is equivalent to minus RT in K, where delta H is the enthalpy, delta S is the entropy of bond formation. Thank you. Have a nice day.